All right, class. So wrapping up chapter 3 here, we're going to talk a bit more about simple versus complex carbohydrates in our diet, and then we'll look at a few diseases that are correlated with the carbohydrates that we're getting from our food and how our body is reacting to them. So in general, there is an RDA of 130 grams per day. Again, most of the dietary recommendations, things like our RDAs, are coming from a 2,000 kilocalorie diet. And so this RDA of 130 grams per day is simply aimed at making sure you're getting enough carbohydrate in your diet to supply your neurons with the glucose that they need. So in order for the average person to be properly supplying energy to their brain cells, to their neurons, you would need to consume 130 grams per day. So if we convert that to calories, right, since carbohydrates have an energy density of 4 kilocalorie per gram, this RDA would provide you with 520 calories per day simply from carbohydrates. However, the recommended AMDR, right, the macronutrient distribution rate, has you aiming for 45 to 65% of your daily calories per day coming from carbohydrates. But if you think about this recommendation for a 2,000 calorie diet, 520 calories divided by 2,000 calories is only around 25%. Right? So this is simply the recommended amounts needed to supply energy to your brain. If you're not getting more than this, you're not providing enough energy for the rest of your body, for your muscles to be able to perform exercise. Right? So this is a really, really low RDA as far as a general goal. Another important thing to consider, besides trying to get enough carbohydrate, so not only enough to supply your brain with the energy it needs, but the rest of your body, it's also important to consider the type of carbohydrate you're getting in your diet. So simple carbohydrates versus complex carbohydrates. And most of the foods that we have available in America, they're really high in their concentration of simple sugars. So whether that's high fructose corn syrup or other sweeteners, we have a lot of these added simple sugars, which can very quickly be absorbed or very quickly be converted into fat, etc. And so, again, these added sugars are sugars and syrups that are being added during food processing in order to make that food more sweet and thus more desirable, trying to take advantage of our natural instinct to prefer fatty and sweet foods. And so one of the most common sources of added sugar that Americans are getting in their diet is soda. And so a single can of soda, so this is not for diet or zero, right? Those Coke Zeros or Diet Cokes, those types of sodas, but a regular Coca-Cola, right, on average, will have around 10 teaspoons of sugar in one 12-ounce can. So just think about a regular cup or a regular can, it's 12 ounces, there are 10 teaspoons of sugar in it. So a teaspoon is a small spoon, but think about setting down a cup of water and just scooping 10 spoonfuls of sugar into that cup of water. That is all in one single can of soda. And on average, Americans consume around 40 gallons of soda each year. This is based on sales data. And so 1 gallon is equal to 128 ounces, or about 11 cans of soda. 40 gallons of soda would provide 5,120 ounces, which is 51,200 teaspoons of sugar per year just coming from soda. And again, these are added sugars, these are simple sugars. And so these cause really high spikes, quick spikes of our blood glucose levels, and then really quick drops, so low valleys of our blood glucose levels, which messes up our body's natural regulation methods. It messes up our ability to react to and release insulin and glucagon. So diets that are high in simple sugars, because of this quick increase in blood glucose, as well as how these sugars can be used by the bacteria in our mouth, have been related to various different diseases. So dental problems such as cavities and gum disease stem from the bacteria that live in our mouth and on our teeth being able to quickly absorb and take advantage of those simple sugars that we're getting from our food. And so these bacteria are going to thrive and thus produce more of that bacteria and thus increase problems like cavities and gum disease. Having higher amounts of simple sugars in our diet also alters our blood lipid profiles. So I mentioned briefly in the last lecture that having a high ratio of high density lipoproteins to low density lipoproteins is healthy and keeps your blood clear from clots. So simple sugars can reverse that ratio and will actually increase the amount of low density lipoproteins and decrease the amount of high density lipoproteins, which can be strongly correlated with heart disease and hypertension or high blood pressure. These simple sugars have a really strong effect on things like insulin insensitivity. So like I said, messing with our body's ability to respond to our natural hormones that are there to regulate blood sugar. And so in insulin insensitivity, it's also referred to as pre-diabetes because insulin insensitivity can ultimately develop into type 2 diabetes. And then lastly, this also promotes excess fat storage and obesity. Like I said, fructose, right? So the sugar that is typically added to make foods taste sweet is much more likely to be converted to fat than glucose is and has a much longer chemical pathway to be able to be stored as glycogen. And so the more added sugars you're getting in your diet, the more likely those sugars are being converted into fat instead of stored as sugar. Complex carbohydrates typically, very often, are going to come associated with fiber. And we already briefly discussed some of the health benefits of fiber. But the adequate intake, so the amount necessary for 50% of the population for fiber is 14 grams for every 1,000 calories in your diet. So if the average diet is 2,000 kilocalories, that is 28 grams of fiber per day. And this is a mark that very few people or a very small proportion of the population in America is reaching. In fact, most Americans are eating only half of that amount. And again, this is just the adequate intake. This isn't the RDA, which would account for 95% of the population. This is just the adequate intake, which accounts for 50% of the population. So there's a very low proportion of our population that is getting the recommended amounts of fiber in their diets in order to promote their health. And so whole grains are a really commonly suggested source of fiber. So again, whole grains keep the shell on their seed, and that shell has a high amount of micronutrients and a high amount of fiber in it. And so all of our processed grains have those shells removed and thus lose their fiber and a lot of their macronutrients. So we can look at this example here comparing a whole grain bread to an enriched bread. And so the total amount of carbohydrate in both of these breads is the same. We have 15 grams, but there is significantly more dietary fiber in the whole wheat bread, 8% of your RDA, compared to 2% of your RDA in the enriched bread. And so you can see from the ingredients, the whole wheat bread has unbromated, stone ground, 100% whole wheat flour and crushed wheat as two of the three highest ingredients if we leave out water here. Whereas the highest ingredient for our enriched bread is unbleached enriched wheat flour. And so you can see some of the vitamins and minerals that have been added back or enriched into this food. But again, most of these sugars are simple sugars. So almost all 15 grams of the sugar in this bread are simple sugars, whereas only 13 grams of the sugar in this bread are simple sugars because we get 2 grams of fiber. And so we have sweeteners that are actual sugar or actual carbohydrate, and we refer to those as nutritive sweeteners. So sucrose, fructose, honey, brown sugar, sugar alcohols, those are all nutritive sweeteners, and they provide energy. They provide 4 kilocalories per gram. But we also have lots of alternative sweeteners. So these are our non-nutritive sweeteners, which provide little to no energy. Right? They're not organic molecules that our body is going to access and transform to provide energy in any way. They are simply there to stimulate our taste buds to make our food taste sweet without actually having any sugar in it. Right? And so these are still chemicals and are still having an effect on our body. So we can still provide measurements or recommendations for how much you should be consuming. And there are upper intake levels where it can get dangerous if you're consuming too much. And so we have a acceptable daily intake value for some of the more common alternative sweeteners like aspartame and sucralose. We have an ADI for acetylcholine, but this one is much less common now. Instead, saccharin has been on the rise as a common alternative sweetener. But because saccharin is so new, we don't yet fully understand it. So there isn't an ADI set for it. But again, these simply cause our tongues to taste sweet in our food, but do not actually contribute any sugar to our calorie count. And so you can see here, essentially this is showing you the relative sweetness, so how much we perceive sweetness from these different chemicals. And so sucrose is our baseline. So this is one glucose molecule combined with one fructose molecule that makes sucrose. So that is our baseline, our reference here. Sugar alcohols taste a little bit less sweet, but then all of these alternative sweeteners are way, 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 way sweeter than sugar. So this is generally healthier than eating foods that are using added sugar to make them taste sweet, right? Because again, those added sugars are very likely to contribute to some of those diseases and disorders we just talked about, and are much more likely to be converted into fat instead of being converted into glycogen. Right. So some common health disorders associated with carbohydrate consumption are diabetes, hypoglycemia, and lactose intolerance. We're also going to discuss gluten sensitivity or insensitivity, as well as celiac disease and wheat allergy, which are all very similar, as they're all related to the proteins that come from our grains. But again, as I was just saying, these stem from protein, not from carbohydrate. But because whole grains are a very commonly recommended source of healthy carbohydrates and fiber, I want to discuss, or these are discussed here, because they're also related to these other diseases, this gluten sensitivity, celiac disease, and wheat allergy, because of the proteins that come with these grains. So anyways, starting with diabetes, all three types of diabetes are related to the inability to regulate blood glucose levels. So your body's regular systems that are in place to try to control how much glucose is flowing in our blood and thus controlling our energy source to our cells have been disrupted in some way, and that produces diabetes. And so there are three different types. We have type 1 and type 2. And although type 1 is referred to as juvenile diabetes and type 2 is referred to as adult onset diabetes, both of these can be developed at any point in a person's lifespan. And then we have gestational diabetes, which occurs during pregnancy. So type 1 diabetes and type 2 diabetes stem from a different cause, but again, both can develop at any point in a person's life. And then gestational diabetes occurs during pregnancy or infancy. So type 1 diabetes is much, much less common than type 2, so only accounting for around 10% of diabetes cases, whereas type 2 diabetes accounts for 90%. And type 1 diabetes stems from the patient's inability to produce insulin. So the hormone that is supposed to communicate to our cells that we need to take in glucose, that there's a lot of glucose in our blood, please take it up. We're not producing, or those patients with type 1 diabetes aren't producing that signal. They aren't producing insulin. And so that sugar just stays in our blood and never gets absorbed. And this causes hyperglycemia. So hyper is a prefix meaning too much of. Hypo is a prefix meaning too little of. Hyperglycemia means there is too much blood, or too much glucose in the blood, so high blood sugar. And so this could be treated by simply just adding insulin to our system. So people with, or patients with type 1 diabetes, when they're eating or when they're about to eat, can just inject insulin into their bloodstream, and thus that will counteract this malfunction, and their cells will be able to absorb blood the way they're, or absorb glucose the way they're supposed to. Type 2 diabetes, which is the much more common version of diabetes, stems from our cells just not reacting to insulin. So again, type 1 was our cells, or our body isn't producing insulin. Type 2 is our body's inability to react to insulin, or at least a reduced ability to react to insulin. Right? And so this is referred to as insensitivity. Sorry, I'm trying to think of the example I wanted to use. Sorry. So you can build up a tolerance for lots of different things, right? And this is essentially the same thing. This is like a drug tolerance. So like an alcohol tolerance, someone who, as you increase the amount of alcohol consumption, you need more alcohol to feel the effects of it. Right? You are building a tolerance. It takes more to produce the same effect. Our body can react the same way to all of our messengers, so including our hormones. And so if your body experiences high amounts of insulin production over short periods of time, eventually your cells are going to build a tolerance and they're not going to react to insulin in the same way. And thus those cells kind of wear out and no longer react to insulin and thus are no longer absorbing glucose from the bloodstream. And so you have too much glucose in the bloodstream, which is, again, hyperglycemia. So type 1 diabetes the pancreas is not producing insulin or not producing enough insulin. Type 2 diabetes, insulin is being produced, but it's been produced too much. And so our cells have worn out and become tolerant to it and no longer react to insulin the way they were supposed to. And so this is much harder to treat, right? Because you can't just inject that hormone into your cells and because the cells still aren't reacting to it. And so this can be caused by a variety of factors, including genetic predisposition. So if the gene responsible for producing insulin is overactive, that can be passed on through generations. Obesity can impact the different chemical messengers occurring in our body, and physical inactivity. So how often your body is regulating its blood glucose levels. And so treating type 2 diabetes is much more holistic. Right? So typically you'll try to tackle all of these things. So changing diet, adding exercise, and even using oral medication to try to help with that insulin resistance. Okay, and so now we're going to move on to all of these three diseases, commonly all referred to as gluten insensitivity. But there are three separate reactions occurring to different types of proteins that come with our grains, our whole wheats. So there are a spectrum of different immune responses, and your immune system essentially is seeking out and finding any kind of invaders, or it's trying to recognize things that aren't supposed to be there. And so any kind of allergy or insensitivity stems from your immune system recognizing something that you actually want as something that you don't want. So essentially making a mistake, right? So we have these receptor proteins that travel on our in our immune cells. Those receptor proteins will bind with something else, such as the protein that we get in our grains, and will cause an immune response because it thinks that is an invader that is dangerous to us. So gluten sensitivity is specifically looking at or specifically responds with immunoglobulin A, which is going to cause local inflammation, so swelling in the area where it is found, and an accumulation of white blood cells. And white blood cells are there to kind of kill off the invaders and destroy any damaged tissue to make sure those invaders aren't spreading. And so this local inflammation and accumulation of white blood cells ends up damaging the healthy cells and tissue in that organ. Right? And this can be stimulated by the proteins prolammin and glutamins, or these are categories. So these can be stimulated by prolamins and glutamins, which are types of proteins that we commonly find in our wheats or in our grains. Right? Celiac disease is similar in that it's another immunoglobulin A response to prolammin, but the effect is different. Okay? So this is specifically looking at the effect that this wheat sensitivity or insensitivity is having on our small intestine. And so our small intestine is specialized and designed to have as much surface area as possible interacting with the molecules that we're digesting, and thus increasing the likelihood that we are absorbing them across our cell membrane. This immune response to prolammin can cause, through that accumulation of white blood cells, enough damage to our small intestinal lining that it ends up flattening all of those villi. Right? So instead of having all of these big ridges with brush borders with lots of microvilli sticking out so that it can absorb a lot of nutrients, this tissue ends up being flattened. And thus we have a much less efficient process of absorption and much less absorption occurring overall. So celiac disease is relatively uncommon, about 0.6 to 1% for the general population, a 2.6% relevance when 2 relatives have it, and 4.5% when 1 relative has it. Right? And all plants that belong to this group, try to say, this is just a family of plants. So there's multiple different species. Essentially, these are all grass-like plants. So wheat, rye, barley produce these proteins, these prolamins and gluteins, right? And so if your immune system is responding to these as invaders or as allergens, typically that is going to result in gluten sensitivity, where there's just local inflammation in a particular area, but it can damage the small intestine, which produces celiac disease. So you can see kind of the changes in the small intestine occurring. This is a literal or an actual electron microscope image of the small intestinal lining for a typical patient compared to a patient with celiac disease. And you can see a lot of the ridges that are along this villi have disappeared. Okay. As well as and then the other sign here are the crypt cells. So these are essentially stem cells used to create more intestinal lining cells and help regulate these intestinal lining cells. And so we usually have a lot of them, and they're relatively small here at the base of all these ridges. But with celiac disease, we get much fewer of them, and they end up taking up more space, so they're much larger. Whereas here we can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 crypts just in this one image. For the same span, we only get 1, 2 crypts. And so these intestinal lining cells aren't being replenished, thus they're starting to flatten and thin out. And so we lose a lot of that surface area that is supposed to help absorb all the nutrients from our small intestine. Okay. And so lastly, we have wheat allergy. So we have a different immunoglobulin response. This is immunoglobulin E, and mast cells responding to gluten proteins. And this causes systemic inflammation. So whereas gluten sensitivity had localized inflammation, so in one area, in one organ, or in one part of the tissue, and celiac disease was specifically looking at that effect on the small intestine, or specifically stems from that effect on the small intestine. Wheat allergy causes an entire system response. So it's not local, it affects the entire body. And so the entire body inflames in response, and thus is going to damage and disrupt other cells like muscles, causing our muscles to constrict, dilate, and spasm in ways that they're not supposed to. And so this allergic response can be potentially deadly, right? So it can cause smooth muscle constriction, such as those lining your airways and that make up your stomach. It can cause muscle spasms in some of our skeletal muscles, so loss of bladder control, and can impact our ability to supply blood to our heart through our coronary muscles, and can cause smooth muscle relaxation, such as vasodilation, so our blood vessels dilate and thus decrease our blood pressure. But wheat allergy is the least common of these three. So typically those that have a gluten intolerance are gluten sensitive. Relatively severe and specific cases of gluten insensitivity can result in celiac disease, which is impacting the small intestine. And then severe gluten insensitivity is actually wheat allergy, which causes a total system response, a total system allergic response that can be potentially deadly. Right? But this is much less common, less than 0.5% of patients with a gluten intolerance or a wheat intolerance actually have wheat allergy. And again, this all stems from the proteins that are common in wheat. We're discussing them here because whole grains are so commonly suggested as a source of healthy carbohydrates, those complex carbohydrates and fiber. So with diabetes, we're seeing that hyperglycemia is a common outcome, so having a high blood glucose level. But hypoglycemia, a low blood glucose level, can also cause issues, right? And so this can stem from what is considered reactive hypoglycemia, which is where your pancreas secretes a large amount of insulin after a single meal, and thus your cells gobble up all the free glucose in your bloodstream, and you don't have any left, and that can leave you feeling like shaky, sweaty, and cause anxiety. Right? Your body is just kind of out of whack. And then you can have fasting hypoglycemia, which results when too much insulin is produced, even though there's not food. So this is typically most common when people are making major changes to their diet, if they're starting to include long periods of fasting. So if you went from eating 3 to 4 meals a day, from when you woke up to when you went to sleep, to all of a sudden introducing a 6 to 10 hour fast period while you're awake, your body may still produce insulin when you're thinking about, smelling, or talking about food, right? Because it thinks food is going to come, so it produces insulin, telling your cells to start taking in glucose, but then you don't actually add any food, and so all the glucose is out of your blood, and thus resulting in hypoglycemia, which again will cause things like shakiness, sweating, and anxiety. Okay, and then the last disorder we'll talk about related to carbohydrates is lactose intolerance. And lactose intolerance honestly just makes sense logically. Humans are not evolved and have never in our evolutionary history relied on dairy or milk as a source of energy beyond from when we are getting milk from like our mothers, right? From when we're breastfeeding. So after the breastfeeding period, humans are designed to not be drinking mammalian milk, right? To not have dairy products as a part of their diets. Right? So using dairy products and having milk throughout the rest of our lifespan has been a relatively recent inclusion in the evolutionary history of humans. And so most of us have our genes that produce the enzyme lactase, which is responsible for breaking down lactose. Most of us have that gene turned off, or at the very least slowed down after we stop breastfeeding, right? And so lactose intolerance is a direct result of that insufficient production of lactase. Lactase is the enzyme that chemically digests lactose. And so if you don't produce the enzyme lactase, your body won't be able to digest lactose. And so all of that lactose is going to go through your entire digestive system and make it to the large intestine, where the bacteria are going to gobble it up because they do make lactase and they can digest lactose. And as a result, they produce a bunch of gas, and that gas is what produces all of these symptoms. Okay? So that bloating, nausea, cramping, and diarrhea, these are all a result of the bacteria in our large intestine digesting lactose and releasing all the gaseous products. Okay? And so those with lactose intolerance have access to lots of other great sources of calcium, like tomato juice, cabbage, beets. And nowadays we have things like Lactaid. Lactaid is literally just concentrated lactase. So if you drink it or take some before you eat a dairy product, you're essentially providing that enzyme that your body needs to break apart that lactose. And so you don't need to produce it yourself. But again, we aren't evolved to rely on lactose as a source of energy, right? And most countries around the world, even today, don't drink mammalian milk or use dairy products as a large part of their diet. That is much, much more common in America than anywhere else in the world. And so again, in general, lactose intolerance just makes sense and is relatively common. Yeah, so that is all for this chapter. As always, please reach out with any questions or concerns, and I will see you guys in the next one.